Hi everybody, welcome back. We are going to do our last day of notes. Today we're doing systems of inequalities. Very similar to systems of equations, very similar to graphing inequalities. It's kind of just the combo of both. So let's go ahead and get started. Quick review. I know you guys did this the other day, but just graphing inequalities on a coordinate plane. 4 steps. Put it in slope-intercept form, graph on a coordinate plane, dashed or solid line, shaded above or below, kind of thing. Okay? And then remember, it's dashed if it's not equal to, and it's solid if it is equal to. Okay? Where shading, you would shade above if it was greater than, either greater than, and you would shade below if it was less than. Okay? So systems of inequalities. Systems of inequalities is just a group of 2 or more linear inequalities. So, and I keep saying 2 or more because as honors, you guys will have to deal with if it's like 3 of them, which isn't that bad because, especially with graphing stuff, you just put all 3 on there and look for, with inequalities, you look for the triple shaded part, and for equations, you just look for where all 3 cross the same point. But that's a system of inequalities. It's just 2 or more linear inequalities, where solutions to a system of inequalities is again ordered pairs that work for the inequality, that make it true. And to find these, we actually put it on a graph and we look at the shaded part of the inequality. So those are the ordered pairs that are in the shaded region of the inequalities. They're the ones that if you plug it into the inequality, it'll give it a true statement. Okay, so here's an example. Ignore the dots that are already there, but find the solutions to the system of inequalities. Now, the one I give you here is different than the one on yours. So this sign is on your paper, it says less than. Please change it to a greater than or equal to sign. Okay, change this to greater than or equal to, because it'll make more sense. So this guy, the bottom one, is already in y equals mx plus b form, slope-intercept. This guy is not. So I have to get this y by itself. And the way I do that is first I'm going to get rid of this 2x. So I'm going to subtract 2x from both sides. So I get negative y is greater than or equal to negative 2x minus 4. And then I need to divide everything by negative 1 to get y by itself. Now when I'm dividing by negative 1, I have to flip the sign. So now it's going to be less than or equal to. Okay? So y is less than or equal to 2x plus 4. And that would be my other thing. I don't know why it's not showing the whole circle, but that's my other equation that I'm going to graph, or inequality I'm going to graph. So I'll graph the blue one first. Slope-intercept is 1, that's why I would dot there. And the intercept is 1. The slope is negative 2/3, so I go down 2 and over 3. Down 2 over 3. Okay? That is my line. You see all these blue dots right here? That's my line. Now, it is just less than, not equal to, so that means this is going to be a solid line, or sorry, a dotted line. I can't talk right now. And then, because it's less than, I actually shade below. So all this stuff, everything blue touches. Those are all solutions to that one inequality, except for these points on this line. Okay? Now I need to graph the other one. Y is less than or equal to 2x plus 4. Well, 4 is my y-intercept, 2 is my slope, so I go up 2 over 1, up 2 over 1. It is equal to, so that means it's going to be a solid line. And it's less than, so I shade below that line. Okay? So I did my shading. Do you see how this section has both red and blue in it? This section is my, those are where I find my solutions, in this purple section. Okay? Which means that little point right there is a possible solution. I could check it by plugging it back in. So I'm checking the point 0, negative 6, plugging it back into both inequalities. So first one works because negative 6 is in fact less than or equal to 4. And test the other one. I get negative 6 is less than 1, which is also true. So I know I've got the correct region for my solutions. Okay? The only way you're going to be able to show the solutions to a system of inequalities is through a graph. Okay? And a lot of times they just like to show you the double region part, so they won't even shade up here and up here because they only shade the region part, the solution part. So just be aware, this part's shaded, but nothing else is. That means it's shaded below this blue line and below the red line, so you could extend the shading if you wanted to. Okay? You guys are gonna, I think that's the only example I did. Yeah, you guys have to try on your own, so one is to actually graph this one and find the solutions. So just show me the picture. And the other try on your own is to write the system of equality. So we did this with the last notes where you guys had to come up with the inequality, but here's an example where it's only shaded in the double shaded part. You could still tell where it's shaded for each of these lines, if it's shaded above or below the line. So try to write the inequality for this one, and then we will come back, or system of inequalities, and we will come back and go over this, okay? Other than that, that's all I got for you today. So if you have any questions, write them down. You can ask me on Remind 101 if you get stuck. But yeah, other than that, that's it. Alright, I'll see you guys later. Bye. Oh, not bye, because I gotta get to the thing. Alright, now bye. Bye.